making a Maclaurin series. But today, or yesterday and today, we were starting with ones that we already knew and then kind of rewriting things so that we didn't have to just like start from scratch with all of our derivatives in order to make it. But we did have one honest example left. So we looked at one where we were kind of like plugging in, or in other words, like kind of multiplying, so we can multiply by things. We can also integrate as needed. Alright, so if we're looking at find a power series centered at 1 for f of x equals the natural log of x, be sure to state its interval of convergence. So looking at that function, okay, is the natural log of x one of our like special series that we're supposed to know?
No.
No. Okay. But let's think about what are our special series that we're supposed to know?
Sine, cosine.
Sine, cosine, e to the x, and then what was the other one that we also used yesterday? It's the other one that we know the sum for. Geometric, right? So we want to be able to rewrite it as one of those, okay? And so for the one we did yesterday, we had e to the, I think, negative 2x, and so it was really easy to use e to the x. Here I have a natural log, and so there's not really a good way for me to rewrite that as either an e or a sine or a cosine. Are we all with me there? Okay. But what does our sum of a geometric look like? Correct. Sorry, what did you say? A
Over 1 minus r.
1 minus r. Yes. So we have a divided by 1 minus r. Agreed? And remember that our r is most likely going to have x's in it. Yes? Because like that's what makes it a power series or a Maclaurin series. Yes?
Yes.
But looking at that fraction, okay, what about a natural log of x is going to give me some sort of fraction? Derivative, right? So I have f prime of x is 1 over x. Yes? Are we all okay with that? But remember, what are we wanting it to be centered at? 1, which means what are we going to have to end up with there being in there? A c value, but how do we write that? X minus c. Okay, so really I need this to be, right, x minus 1. Yes? But am I allowed to just put in a 1 because I want to? No, but what could I also do? If I subtract a 1, I could also add a 1. I'm just going to happen to do that on the front side. So does that still equal my original derivative? Yeah, so I can have that equal sign there. And also, what's nice? What is this looking closer and closer to? My geometric series. Are we okay with that? Okay. The only thing is, what's wrong with the bottom right now? It's addition, but that's pretty easy to take care of because addition is the same thing as correct. So I can change it to that instead. Are we all okay with that? Again, we're working our way, kind of like we did with our e to the x, we're working towards a formula or something that I know a series summation for. Geometric is a good one. And so that's why we took the derivative to get a fraction. Now, we will have to eventually untake the derivative, right? Which is also integration, right? But we'll get to that in a minute. So what is our a value here? What is our r value? Yeah, negative parentheses x minus 1 or negative x plus 1. Either one's fine. 1 n equals 0 to infinity of, what comes first? A, what's our A? 1. We always need to size checks. It's just our class representative. So then it's A sub 1 times R to the n power. Yes? Which again, I got my R just from looking at my equation. But looking at that, how might we probably write that instead? What do we tend to do with our negatives? Correct? Yes. So it would be negative 1 to the nth power times x minus 1 to the nth power. Well, that's helpful because now that's looking closer to a power series, right? Where I have x to the n for x sub n times x minus c to the nth power. Agreed? Are we all okay with that? Yes, maybe. And that equals what? What did I create a power series for?
1 over x.
Technically created a power series for 1 over x, yeah? Which isn't my original function. Agreed? So I'm trying to create a power series for my original function. Agreed? Are we all with me there? Okay. So this all technically equals f prime of x. This is the power series for 1 over x centered at 1. Agreed? But again, we talked about how do I undo a derivative? Take the integral. So I have f of x equals the integral of my summation right? And what am I taking the integral with respect to? That's important.
N,
No.
x.
Yes. We would not have a fun time if we were trying to take the integral with respect to n. Because my summation is in terms of n, right? But my function is in terms of x. So I'm trying to get my function to go backwards to f of x, which means that I need to take the integral with respect to x, which is a whole lot easier. Because realistically, even though there's a lot of like variables here, right? If this was x minus 1 to the nth power, okay? N is just a what?
Number.
Constant. It's just a number, right? So what rule do I use to take the antiderivative of that? I had x squared, or x minus 1 squared. What do I do?
1 over.
It would technically be a u sub, right? But my du is going to be 1, so I don't really end up having to do it. And so then it's just a power rule, right? I add 1 to my exponent, and then I divide by my new exponent. Agreed?
Yes.
Okay, but realize that that integral does not affect my summation. Are we all okay with that? Because again, my summation is in terms of n, my integral is in terms of x. Yes, no, maybe. So I still have a summation there. But in order to drop my integral, which is what I need to do, I need to take the antiderivative of my stuff with x's. So what would we do with our n? Add 1. And then I also need to 5. Okay. And then since negative 1 to the n, right, is just in terms of n, it's not going to change anything for that. Yes, no, wait. Then the only thing that we do need to think about, okay, is that you could leave your answer like that, that's fine, okay? But remember that we usually have an a sub n times x minus c to the what power? N power, right? So we're not quite there. We agree? But in order for me to be able to adjust this, okay, I also have to adjust where I start. okay with that? Because I can't change the values that I get here. So notice that if I plugged in 0, what would I get as my exponent? 1, okay? So if I just wanted to have an n here, what would I need to adjust my bottom starting spot to? 1. So that way I still get a 1 as my exponent. Which means that I also have to adjust my others. So this now just becomes n, and this becomes -1. I also have to go backwards 1 with that one as well. So now that becomes n minus 1. Now again, we can technically leave it like this, and you would be fine, right? But if we needed to use this for something else, or if it was a multiple choice type question, which I don't, most of your power series stuff isn't going to be a multiple choice question because it takes a little bit, but for something that was maybe a little bit simpler, they are usually going to adjust those so that you just have an n. Yes, no, maybe. Okay.
If their calculator active, is it beneficial to take the extra time to plug both in and Desmos and see if they like line up to check your answer?
Like the summations?
Yeah.
Summation, I don't believe it will allow you to do an infinite sum.
Oh yeah, you have to like do a really big number.
Yeah, or you would have to like creatively like write it as a function, which like we already have x's going on there, so like it would be a lot to try and do that. Alright, so let's look at our second one.
Wait, what was the interval of numbers?
Oh, sorry. Yes. That's not what I wanted.
Alright, so the nice thing about us reading it as a geometric is, what is our interval for convergence for geometrics? What does R have to be less than?
1.
1. Where's the absolute value part, yeah? And what's our R here? Almost. Negative. Which at the end of the day, it's not gonna like matter a whole lot because we take the absolute value of that. Yes. But my absolute value, I can go ahead and drop my negative, but I have x minus 1 is less than 1 is greater than negative 1. So maybe. So what do we get? X is less than 2, but greater than 0. Is 1 the center of that?
Yeah.
Yeah. And remember, with our geometrics, we don't end up having to check our endpoints because of that fraction that we have. So we don't have to go through to test those end values. So let's look at one more. Very similar, but with arctangent. So same idea, okay? This time I'm centered at 0, so that makes my life a little bit easier. If I wanted to rewrite this, does arctangent already look like one of our 3 big ones, sine, cosine, or e? No, and there's not a way to rewrite that nicely, okay? So if it doesn't look like one of those, we generally want to fall back on our geometric. Yes? Okay, so is there something that's related to arctangent that might look like a geometric? Yeah, what's our derivative of arctangent?
1 over
okay with that? So then how would I rewrite that just to get it a little bit closer to and geometric? Alright, okay with that. And we're centered at 0 this time, so I don't have to worry about needing to add in an x minus something. So that makes it a lot easier. So what's our a value? What's our r value? Okay. So then what would our summation be? For f prime. Negative x squared, what? Yeah. Yes, what maybe? But then what we're gonna do? Not yet. We need to separate some stuff first. So I have -1 to the n times what? Which is the same thing as x to the 2n. Again, we're trying to clean it up a little bit so that's just easier to integrate so that I can just, this time we would just straight up do a power rule. So again, we're trying to go backwards. So if I wanted f of x, I need to take the integral of that thing. Okay. Notice that we're doing integrals here, because I actually think integrals are a little bit harder, but you could just as easily do a derivative of something. Does that make sense? So like if whatever we were starting with, right, the antiderivative looked closer to whatever we were trying to get it to look like, yeah, then I would take the derivative of both sides, okay, again with respect to x, in order to get back to my original function. Are we all with me? So it goes both ways. Remember, I just have my function, but we are taking the antiderivative with respect to x. So does it affect my 1 to the n? Not all x there. So then what would we need to do in order to take the antiderivative of that?
Add 1 and then divide by the new exponent.
So we get that. Be careful here because I'm not plugging in n plus 1 like I do with some of my stuff, right? So that's why I don't have to distribute the 2. I am just adding 1 and dividing. Okay? And if we wanted to write that again a little bit nicer, what might we do? Start at 1. So I would have -1 to the n minus 1 times x to the 2n divided by 2n. But those are equivalent, so you could have either one. What questions do we have there?
Why would we not need a plus C?
We could technically put in a plus c, but then notice that like we are centered at 0, so I would use that point. So 0, if I plug that into my original is 0, so my c would be 0, and that's how most of these can be for these. Also with like these ones, right, again, because I'm going to be centered at whatever I'm subtracting here, it's going to give me a 0 if I plug that thing back in, and so we end up with constants of zeros. So, like, you could technically write it, but it's going to be 0, so we usually just